cloud. And now we're going to talk about 5 ways to get students thinking about microgravity experiment design. So if I'm a student and you facilitated an understanding so far, I understand what classic experiment design is. I understand that the essential question for a microgravity experiment is what is the role of gravity? So I need to change the gravity variable. If you so want to go into that, depth of explanation, I now understand that if I'm in that elevator, well, it's a freely falling laboratory, and inside that elevator, it's as if gravity's turned completely off. And the International Space Station, with the ping pong ball analogy, is a continuously freely falling laboratory. So a microgravity experiment is done by bringing one experiment to station where it'll operate in the seeming absence of gravity, and we run the same experiment on the ground as the control. So the comparison of the two allows us to understand the role of gravity in what I'm studying. If you want to cut to the chase and say, in a freely falling laboratory, whatever that is, like the International Space Station, the astronauts appear weightless, and you don't want to go through the elevator thing, that's up to you. But then if I'm a student that is really curious, I don't get why the astronauts are weightless. But the elevator analogy brings it very crystal clear to me, okay? So it's up to you to figure out if you want to go to that depth. And now as a student, I understand the mini lab is small but capable. I understand it's used from upper elementary through undergraduate institutions. I have examples of 2 experiments. And now the big question for students is, okay, I get it, but now my team has to come up with a microgravity experiment. How am I even going to think about what kind of microgravity experiment we want to do? So now I want to give you 5 different ways that students can come up with a microgravity experiment. So the first thing is they need to read the Minilab operations page backwards and forwards right out of the gate to understand the engineering and technology constraints on experiment design. They need to understand what the Minilab can do and what the Minilab cannot do. So if they don't understand what the Minilab can do and they want to put up something this big, right, this big, well, that's not going to pass flight safety review because it doesn't even fit in the Minilab. If you want to put up something radioactive, well, that's not going to pass flight safety review because there's not going to be a way that they're going to let a radioactive material go up. If you want to fly something that has concentrated sulfuric acid, we have a problem with that. So you need to understand the Minilab operations page backwards and forwards first so that you know what it can do and what it can't do. So the first of 5 ways for students to get ideas is to look around their world and say, wow, that's really cool. I wonder what the role of gravity is in that. And I happen to know that will work in the Minilab. So one example is a young lady who was a junior in high school remembered the biology lab the year before, and the lab that really floated her boat was the planaria worm regeneration lab. So she said, gee, I wonder what the role of gravity is on planaria worm regeneration. What a cool question. Another young lady in elementary school, I think 5th grader, went down to her basement one day and it was damp down there and she saw moss growing on an inside wall. And she said, gee, I wonder what the role of gravity is on the life cycle of moss. That's how that experiment happened. So you look around your world and you dare to ask the question, I wonder what the role of gravity is on that. A second way to do it is your students can do research online to see what kind of microgravity experiments have already been done in space and see if there's something that is interesting to them. A third way to do it, and we'll get to the website, a third way to do it is to go to the document library and you can download the microgravity science background document, which has an overview of 9 separate science disciplines appropriate for microgravity research and why, like crystal growth, like protein crystal growth. And there's an accompanying case studies document that gives examples of experiments in each of those 9 science disciplines. So you can read about those disciplines appropriate for microgravity research and see examples and get ideas. A fourth way you can do it is you can download the microgravity experiment samples document, which lists hundreds and hundreds of fluids and solids that are typically used for microgravity research, microgravity experiments, and you can get ideas there. And a fifth way to do it is you can go to the website and your students can read over 400 one-paragraph summaries of every flight experiment ever conducted via SSEP. And if they want to do one of those experiments over again, they can. If they want to do one of those experiments a little differently, they can. What's really important to say here, a few things. We are not expecting your students to add to the human book of knowledge with something completely new. We're immersing them in real experiment design constrained by real world engineering and technology constraints, writing a real proposal, going through a real research proposal competition. The deliverable to you is a formal proposal from each team. It is written against the template in the proposal guide. It has a section where they describe the microgravity experiment they want to do, and they have a justification for why this is a good microgravity experiment with citations in the proposal and a bibliography. There is a section on the procedures. How are you going to do this experiment in space? How are you going to do this experiment on the ground? If you have trial data that you've worked out trials with test tube volumes, put that in the proposal. And then there's an analysis section. How are you going to compare the two experiments when the flight experiment comes back? What is the analysis that you're going to do? How are you going to do this analysis to see if you answered the original question that you put forward in the beginning? And you cannot get a proposal from a one-paragraph summary of an experiment. There are no proposals on the website. We will send you exemplars of experiments that were selected as flight experiments so you can see what a winning proposal looks like at the elementary, middle, high school, and undergraduate level. But you cannot and must not share those proposals with any of your students. So the deliverable is a formal research proposal. And if they want to read a one-paragraph summary of 400 experiments in lots of different disciplines and lots of different grade levels, even at the undergraduate level, they can to get ideas. So does everybody understand how this works? So now the last chapter here is the website navigation. You've all been hanging in there for a long time. Pam, how much of a break should we have before we go back to website navigation?
Honestly, I think we should just kind of keep going.
Does everybody want to, okay, you have some smiles. I don't know. You want to
That's fine. That's fine.
What?
Maybe Dr. Goldstein needs a break because
Is
he's been talking. Is that right?
What?
I think maybe that's true. Shall we take a couple-minute break?
Why don't you take a 5-minute break?
Why
and
don't
then
we
come
take
back to
5?
navigation?
Bathroom break? All
All right,
right.
so let me go ahead and stop the recording. Pam, I'm so sorry I didn't record one of the chapters.